Okay, chapter 2, projectile motion. This part only and projectile motion only. Okay, to start with the object which is given an initial velocity and afterwards follows a path determined by the gravitational force acting on it is called projectile. And the motion is called projectile motion. These are the common example. If a person throws a stone or a ball in this direction, so it is one of the example of projectile motion. It is two-dimensional motion. Okay, so another example, if this one is projected at a certain angle, this also shows two. One is in the x-axis, the motion in the x-axis, the other is in the y-axis. That's why we say it is two-dimensional motion. This is the best example. Okay, when a bomb is dropped from plane, so it's another example of projectile motion. So in our day-to-day activity, we have a lot of projectile motion. For example, if the arrow is released in this direction, if the target is here, so the motion of the arrow is curved motion, not a straight line motion, due to the gravitational force, the presence of the gravitational force. Proceed to the important pointers that we need to consider in projectile motion. The first thing that we need to is velocity of the projectile. The velocity of the project, this is U, is an example of the velocity of the project, which is the velocity with which the body is projected. The body is projected in this direction at certain angle theta. So this angle theta, the angle between the direction of the projectile, this projectile, and the horizontal plane passing through the point of projection is called angle of projection. And the other thing, the very important thing that we need to look is this one, which is the trajectory. The trajectory, this is the trajectory. So this trajectory OB is found in your text, but here we have this symbol which is shown by the blue color. So this the path described by the projectile from the point of projection. This is the point of projection. This is the point of projection to the point where the projectile reaches. This is the point where the projectile or the ball reaches. Then the horizontal plane passing through the point of projection is called a trajectory. So these are the important points that you need to consider. Okay. Having this in mind, there are two components for this velocity, for this one. So the first one is the horizontal component. The second one is the vertical component. The horizontal component is given by ux is equal to u times cos theta, and the vertical component uy is given by uy sine theta. So throughout the motion, the horizontal velocity never changes, it's constant. From this, the point of projection to the arrival, this horizontal velocity u cos theta is the same, but there is a change in the value of u sine theta. For example, at this point, you will get the maximum value of the vertical velocity, which is represented by u sub y, which is equal to sine theta. But at the maximum point, the vertical velocity is 0, but the horizontal velocity is constant, which is u cos theta. So for projectile motion, ay, the acceleration due to gravity, we can represent by minus g. When you release a ball downward, it accelerates, but in the upward direction, it is deceleration. So that's why we represent by minus sign, minus 9.8 meter per second square, or sometimes it's possible to use minus 10 meter per second square. So the x since the horizontal velocity is constant, so the values of the ax is equal to 0. So because of there is no force acting horizontally. Okay, now let's proceed to the other one, motion. So change in x, which is equal to u sub x multiplied by t plus half times x t. So this is a representation of the motion in the x-axis. So we have change in x means x final minus x initial for the time being, we consider that the x initial is 0, the y initial is 0, so x final can be given as, because x final minus x initial is equal to x initial is 0, so x final is equal to the horizontal velocity is always constant, as I told you before. Therefore, we can say instead of ux, I can put u cos theta multiplied by t plus the acceleration in horizontal direction is the velocity is constant, therefore the acceleration is 0. It become half 0 t square. Let me show you using marker. Okay, therefore x is equal to u cos theta, which is horizontal velocity, multiplied by t plus half times acceleration in the x direction times t square. You know that this value is 0, therefore 0 multiplied by this one, and finally the x final, this is x final, because x initial is equal to 0, therefore x final is equal to u cos theta multiplied by t. This is the values of x at a certain time t. Okay, so having this in mind, now let's find, this is for horizontal position, and so for the vertical position, which is equal to change in y value, y multiplied by t plus half ay multiplied by t. Okay, this is t square. T square, you know that change in y means y final minus y initial is equal to u in the y direction times t plus half ay in the y direction, which is represented by the values of y in the vertical, which is equal to minus values of y, so it represented by minus g. You know that ay is equal to minus g, so t square, so y initial is equal to 0, so y final is equal to, this is u multiplied by sine theta, u multiplied by sine theta. This comes from the two components, as I told you before. Let me show you again. In a projectile motion, this is the trajectory, so this is the angle theta. The horizontal ux is equal to u multiplied by cos theta, but the vertical one, this one, is equal to u multiplied by sine theta. So this is uy and this one is ux. Ux is throughout the motion is constant. Ux is the same throughout the motion, but there is a change here. Uy is equal to 0, but ux is constant. Ux is constant. Ux is constant, but uy is increasing. So this uy is greater than this one. Okay, so but in the direction is downward. So having this, now is come to this one. So y final is equal to sine theta multiplied by t plus we have half multiplied by minus g times t square, or the y final can be written as sine theta multiplied by t minus half g square. This is the values of uy. Having this in mind, now let's see the horizontal component velocity, where vx is equal to ux plus ax multiplied by t. Vx is equal to ux, this is ax value, plus this is 0, you know that 0 multiplied by t, so the horizontal component is simply equal to u multiplied by cos theta. But the vertical components, of the velocity Vy is equal to Uy plus the acceleration in the y direction multiplied by t. You know that this is minus g, so Vy, the vertical component, this is the initial, which is u times sine theta. Acceleration is minus g times t. We have to consider acceleration due to gravity. This is the vertical component, and this one is the horizontal component. Okay. Okay, next to this we'll see horizontal range, and we have to see horizontal range and the maximum height. Okay, so in order to get the horizontal range maximum height, you know, this is the projectile, so this is the trajectory, so the maximum height is, this is h max, and we have ux and the vertical uy. This is the u value and an angle theta. So we have to consider two things. One is this one. Let's say this is point A, the point where the projection starts here. So this is point B, where uy is equal to, in this case, is equal to 0. So considering these 2 points, so uy final, which is equal to 0 value, is equal to uy initial minus acceleration multiplied by t. So this value is 0 already, so you have uy initial minus g times t. So this is equal to uy initial g times t. So uy initial is already known, so uy initial uy initial multiplied by the acceleration times t. So uy initial is multiplied by sine t, which is equal to g times t. If you want to find the time, so divide both sides by acceleration due to gravity, then you get this time. So for half trajectory. But if you want to find, let's say this is t1, it's the same t1. So if you want to find t2, let's look back. From here up to this point, we can say t1. From this point up to this point, we can say t2. So the total time t total is equal to the sum of the first, which is t1, plus the second, which is t2. Therefore, t1 is here, so we have equal time. The time from here to here, is equal to the time from here to here. Let's say from A to B is equal to B to C. Therefore, where time A to B, which is equal to T1, is equal to time B to C, which is equal to T2. Therefore, if these two times T1 and T2 are equal, therefore total time can be written as 2 times T1. Therefore, total time, which is equal to 2 multiplied T1, is your sine theta over d. So this is the values of the total time. So having this in mind, now let's go to finding the range. Range is equal to which is the horizontal distance. We have to take the velocity in the horizontal direction, which is ux times the total time, total. So the velocity in the horizontal direction is u cos theta, and the total time is, we already found the total time here. Here is the total time, which is 2 times u times sine theta over g, the acceleration due to gravity. 2 times u times sine theta over the acceleration due to gravity. And therefore 2 u times u is u square, 2u square sine theta cos theta divided by the acceleration due to gravity. Therefore, now rearrange this one, u square 2 times sine theta cos theta divided by the acceleration due to gravity. And you know that from trigonometry, sine theta plus theta, which is equal to sine theta cos theta plus cos theta sine theta. So sine theta plus theta, sine theta plus theta means sine 2 theta, which is equal to sine theta cos theta, sine theta cos theta, they are the same, so it is 2 times sine theta cos theta. Therefore, 2 times sine theta cos theta, these 2 times sine theta cos theta over the acceleration due to gravity can be replaced by this one. Therefore, range is equal to u square sine 2 theta divided by the acceleration due to gravity. So this is how you are going to find the range. So range is equal to simply u square sine 2 theta over the acceleration due to gravity. So in this projectile motion, this is the range. You can represent range from the point of projection to the end point is represented by range. So how do you find the maximum range for a constant u value if you have theta? So how can we find the maximum value? In order to find the maximum value for range, let's start from the formula where r range is equal to u square sine theta over the acceleration due to gravity. So this sine theta, in order to get r max, this sine theta should be equal to 1. So sine 2 theta is equal to 1 when theta is equal to 45 degree, because 45 multiplied by 2, which is equal to sine 90 degree, which is equal to 1. So R max is equal to u square sine 2 multiplied by 45 degree divided by the acceleration due to gravity. So R max is always equal to u square over the acceleration due to gravity. Okay, now let's see the maximum height. For maximum height, y final is equal to times sine theta multiplied by time minus half dt square. We start from this formula. We have seen this previously. So you sine theta times t half dt square. Now let's substitute the values of t in each one of them. So the y final for maximum height. So the y initial is already known, this value. So the y final maximum height, so y final u sine theta times t plus half gt square. So okay, now y final, in our case we have to look for h max, so u times sine theta. So to get h max we have to consider only t1. The maximum height is found at time t1 minus half times the acceleration due to gravity t1 square. So h max, which is equal to sine theta multiplied by the acceleration due to sine theta, u times sine theta over the acceleration due to gravity minus half times acceleration due to gravity u sine theta over gravity whole square. Okay, now h max, which is equal to u sine theta times u sine theta, which is equal to u square sine square theta over the acceleration due to gravity minus, we have here acceleration due to gravity half multiplied by acceleration due to gravity. This square means u square sine square theta over g square. So this cancelled by this one. So finally, what do we have? U square sine square theta over acceleration due to gravity minus u square sine square theta over 2 times the acceleration due to gravity. Here we have 2. Okay. So now h max we have common is 2 times the acceleration due to gravity divided by g. We have 2 multiplied by this one, 2 u square sine square theta minus, and this one is u square sine square theta. So h max is equal to, subtract this one, we have only 1 u square sine square theta over acceleration due to gravity. So this is how we get the values of h max. So having this in mind, the projection in terms of angle can be divided into 3. The first one is when theta is equal to 0, which is horizontal projection, when theta is equal to 90 degrees, which is vertical projection, when theta is between 0 and 90 degrees. So these are common division, so we can apply for this formula h max and the other in these 3 cases.